Dear students of class 9, dear students of class 9, we have studied about the representation of decimal form of decimal form of rational numbers. Now today we will solve exercise 1.1, class 9th. Maths chapter 1 exercise 1.1. Very short answer type question. Very short answer type question. First question, state whether the following statements are true or false. Now first part, also give reason for your answer. Also give reason for your answer. First part, every whole number is a natural number. Every whole number is a natural number. Is this statement is true? No. This statement is not true. Not true. Why? क्यों ट्रू नहीं है? क्योंकि होल नंबर में जीरो आता है और जीरो जो है एक जो है नेचुरल नंबर नहीं है. Not true because whole number contains zero, which is not a natural number. क्योंकि जीरो जो है एक होल नंबर है, वो नेचुरल नंबर नहीं है, इसलिए हर एक होल नंबर हमारे जो है नेचुरल नंबर नहीं, एक्सेप्ट जीरो, ऑल होल नंबर्स are natural number. And second statement, every integer is a rational number. Every integer is a rational number. Rational number. Yes, this statement is true because every integer can represent in the form p by q. Statement is true because every integer can be represented in the form p by q, where p and q are integers. And q are integers. Third statement, every rational number is an integer. Every rational number is an integer. No. Every rational number is an integer. Answer, no. Why no? क्यों? Every rational number is an integer because rational numbers also contains fractions. And fractions are not integers. So, every rational number is not an integer. No, every rational number is not an integer because rational numbers contain fractions also. And are not integer. And fourth, if any rational number p by q is an integer, then q equal to plus minus 1. Q equal to plus minus 1. Yes. Answer will be yes. If any rational number p by q is an integer, then q equal to plus minus 1. Yes, it is true. Because if q equal to positive 1 or negative 1, then p answer yes, the statement is true. True, because when q equal to plus 1, then p by q equal to p, and when q equal to minus 1, then p by q equal to minus p, which are integers and rational numbers also. So for it means if any rational number p by q is an integer, then q equal to positive 1 or negative 1. Now next problem, second question, write the following integers in the form of rational number p by q. Very simple problem. Second problem is very simple problem. Write the following integers in the form of rational number p by q. First problem, 9. 9 can be written as 9 by 1 equal to 18 by 2. But for a rational number, there is another conditions that which is p and q have a common factor 1 only. 1 के अलावा कोई और दूसरा कॉमन फैक्टर नहीं हो सकता है, तो उसको हम सिंपलेस्ट फॉर्म में लिख करके ही रखेंगे. सेकंड पार्ट -13 इज रिटन है minus 13 by 1. Third part 30 by 1. And now third question. First part. Is P by Q a rational number? Rational number. If P equal to 0. If P equal to 0. So solution. If P equal to 0, then P by Q is written as 0 by Q equal to 0. Which is a rational number. Which is a rational number. Because 0 can be represent 0 by 1, 0 by 2 या फॉर्म P by Q. 0 को हम लोग P by Q के फॉर्म में रिप्रेजेंट कर सकते हैं, इसलिए 0 हमारा एक रेशनल नंबर है. Second part of third question. Is P by Q a rational number? Rational number if Q equal to 0. And solution. If Q equal to 0, then P by Q is an undefined value. If Q equal to 0, then P by Q represent P by 0, which is infinity, means an undefined value. Then when Q equal to 0, P by Q is not a rational number. Is not a rational number. And next problem. Question number 4. Fill up the blanks with the word terminating, comma, non-terminating, comma, repeating. In the fourth problem, unchanging, first write question here and fill up the blanks, fill up the blanks with the word terminating comma non-terminating comma repeating. First part, on changing 7/16 to a decimal, on changing 7/16 decimal representation will terminating decimal representation will terminating because 16 equal to 2 raised to the power 4. And in second part, on changing 3/25 to a decimal, it will be also terminating. 3/25 decimal representation will terminating because 3/25 equal to 3/5 raised to the power 2. Here 25 equal to 5 raised to the power 2. It means 5 raised to the power m or n. When denominator is a number of power 2 raised to 2 or power 5 or power both 2 raised to the power m into 5 raised to the power n, then the decimal representation of such rational number will terminating decimal. And third part of fourth problem, Seven by 12 decimal representation of 7 by 12 will non-terminating because 12 equal to 2 raised to the power 2 into 3 raised to the power 1, because denominator is not only power of 2 and 5, it contains an extra number as a prime factor, which is 3. तो प्राइम फैक्टर में डिनोमिनेटर के 2 और 5, 2 और 5 के अलावा कोई भी नंबर नहीं होनी चाहिए। अगर ऐसा है तो वो नॉन टर्मिनेटिंग रिपीटिंग डेसिमल होगा। एंड फोर्थ प्रॉब्लम, if denominator of a rational number p by q has prime factor 2 and 5 only, then p by q can written in terminating decimal form. If denominator of a rational number p by q has prime factors 2 and 5, only, then p by q can be written in terminating decimal. Next, question number 5. On writing following rational numbers in decimal forms, state which have terminating decimal expansion Then first part 2 by 11 is not terminating because denominator is 11, which cannot be written as prime factor of 2 and 5. So it contains non-terminating decimal. Similarly, 5 by 9, second part 5 by 9, same, is not terminating decimal expansion. Third part 9 by 16, terminating, because 16 can be written as 2 raised to the power 4 or as prime factor of 2. And fourth part 11 by 30 equal to 11 upon 2 into 3 into 5. 30 contains 3 as a prime factor also. So not terminating decimal expansion. Not terminating decimal expansion. So students, today's video is over today, and in next video I will solve the remaining problems, and you will solve same types of problems from any book as homework. This exercise is taken from Advisor's publication book, so you can solve from any book. Okay, thank you.